Dear students, today we are going to learn about LC oscillation and how we will see how the energy is transforming from one type to another, and at the same time there is conversion in stages which we shall discuss right now. You see, we have LC tank circuit over here and we are applying some alternating EMF across this tank circuit. Then what happens initially, the capacitor gets charged, taking the energy from the outside source. But once it gets charged, even now if we disconnect it from the outer source, still you will see that the energy what the capacitor has acquired, the electrical energy, that starts discharging. The capacitor starts discharging through the inductance coil, and as a consequence the inductance coil gains some magnetic energy at the cost of electrical energy lost by the capacitor. So if we consider the electrical energy of the capacitor in the first stage, when it has just been charged by the external source, then in that case you see that capacitor is fully charged in one sense. And now even if it is now if we connect it, isolating it from the outer source, it is not taking energy from any source, rather the capacitor itself gets discharged through the inductance coil. So at this stage, if we talk about the electrical energy stored in the capacitor, we have electrical energy stored equal to Q0 square divided by 2C, where Q0 is the maximum charge stored by the capacitor in this stage. But the general relation for the electrical energy stored in the capacitor is half Q square by C, where Q is equal to Q0 sin omega t or cos omega t, whatever expression we select. So now you see the electrical energy in this stage is maximum equal to Q0 square by 2C, and the magnetic energy stored in the inductance is 0 because no current has started flowing through the inductance coil. Now the moment the circuit is completed, the inductance and capacitors are joined together in parallel, then what happens, the capacitor starts discharging, and due to the discharge some current flows through the inductance coil, and this causes some magnetic field to get stored in the inductance, and therefore in this stage there is some loss of electrical energy stored in the capacitor, and equally same amount of magnetic energy gets stored in the inductance coil. Therefore we take that electrical energy lies between 0 and Q0 square by 2C, where C is the capacitance of the capacitor, and magnetic energy UB lies between 0 and half L max square, where L is the inductance of the inductor. And you see, finally when the capacitor gets fully discharged, what happens, the total electrical energy is now stored in the form of magnetic energy, is stored in the form of magnetic energy in the inductance coil, and the capacitor is now fully discharged. So that means in this stage the electrical energy stored in the capacitor is 0, and the magnetic energy stored in the inductance is maximum equal to half L max square, which must be ideally equal to the total maximum electrical energy stored in the capacitor at the time of start. And then now the inductance coil, once it is not being charged, no current flows through the inductance coil, now it gets discharged. Because of that, some EMF is back EMF is generated due to change in magnetic field associated with the inductance coil. Some back EMF is generated, and so the capacitor, which was initially charged positive on the upper plate, gets positive charge on the lower plate due to discharge of the magnetic field associated with the inductance coil decreases, and so back EMF is generated. Due to this, the capacitor starts getting positively charged. The lower plate of the capacitor starts getting positively charged, and finally a stage will come when the inductance coil is completely has lost completely its magnetic field, and equivalently electric energy is stored in the capacitor. But in this case, the capacitor is oppositely charged as compared to the starting stage. So that means what you see is the half cycle of the oscillation is completed. Means now the whole process as narrated from step 1 to 5 will be 4 will be repeated, and finally the capacitor will have the upper plate positively charged and lower plate negatively charged. So that means the whole cycle will be completed. And if you compare it with, here you see also the electrical energy stored in this stage is somewhere lying between 0 and Q0 square by 2C, and also the magnetic energy stored in this stage is lying between 0 and half L max square, Li max square. And finally in the fifth stage, what you see, the electrical energy is maximum and magnetic energy is minimum equal to 0. And this in these 5 stages, it has completed the first half cycle of the oscillation. And the second half of cycle of the oscillation, the whole thing will be repeated in reverse sense. Means the current will start flowing from the positive plate towards the inductance. Inductance will get magnetized, and that further will get magnetized to have maximum magnetization, but this time the sense of magnetization will be reverse of the previous stage. And finally then the discharge of magnetic field associated with the inductance coil will take place, and this time the back EMF will be such that the upper plate of the capacitor will get positively charged, and finally the capacitor will be getting fully charged positively on the upper plate and negatively on the lower plate, while the inductance will lose all its magnetic energy. And so that will complete one oscillation, and the whole thing will repeat. Ideally, if there is no loss of energy, that means the resistive loss is 0 in this case, which is not true in any practical circuit. But if we take it like that, then the oscillation of LC tank circuit will continue for infinite time. But even if there is some loss of energy, if we keep supplying the shortage in energy, then very minimum amount of energy will be required to keep the oscillation. And this circuit has great many applications in so many electrical and electronics equipments. So that's all for today. Thank you and have a nice day.